So our next topic is projections. Projections. What do we mean by this thing? Projections mean, you can say, it is the decomposition. It is the decomposition of a vector. It is decomposition of a vector. To explain this thing, let us consider an xy plane. Okay, and in xy plane we have this point xy, and suppose that we are standing at the origin. So our main goal is we have to reach this point P by moving along the directions I and j. Okay, we know that the unit vector along x-axis it is I, and the unit vector along along y-axis it is denoted by j. So how can we do this thing? If what you have to do, you have to draw a perpendicular line from the point P to the x-axis. Now this distance from the origin to this thing, it is denoted by x, and from this point P, this vertical distance to the x-axis, it is denoted by y. Okay, and here we have this OP. So this vector OP, it can be written in this form. We have discussed this thing in the first section, xi plus yj. As I told you before that I and j are the directions. I and j are the directions, so it means that you can only make movements, mean to the left, to the right, or you can move up or down. So these are the degrees of the freedom. So when you want to reach the point P from the origin, what you have to do, you have to move x units in the direction of I. So what is the meaning of xi? Xi means that move x units, or you can say x kilometers in the direction of the unit vector I. Okay, so in this case there are two things. X, we call this, x is a number. Okay, x is a number, we call this a scalar. It tells you how much distance you have to travel along x-axis, and when I multiply this x with I, it means that you need to travel this much units in the direction of I. So together this is called a vector. So this is a vector. So only if you consider x, it is a scalar, and xi mean the vector. So this is kind of a projection. This is kind of a decomposition. Decomposition mean this thing, it will tell you how much distance you have to travel along x-axis, and how much distance you have to travel along y-axis or in the direction of j. So similarly, suppose that if we have a vector A, okay, and we have another vector B. Okay, they are not you can say same like I and j. So what you have to do, from the head of the vector B, you need to draw a perpendicular line to the vector A, so that here you have a 90-degree. Okay, so from this point to this thing, this is same like x. Okay, this is the same like x. So if you only consider the how long it is called the component or scalar component of the vector B in the direction of the vector A. So this thing, with this thing, there are two different types of the projections associated with this. Okay, two different types of the projections. The number one, it is called the scalar. It is called the scalar projection. Okay, the number one, it is called the scalar projection, and the second one, it is called the vector projection. So the number one, it is the scalar projection. Okay, and the second one, it is called the vector projection. So how can we do this thing? How, by which formula we can find them? We are going to discuss this thing below. We have the following definition. Okay, we have this definition which gives us the formula for finding the scalar projection and the vector projection. Okay, so the scalar projection, it is denoted by this formula. Okay, the scalar projection, it is denoted by this thing. It is called the component of the vector B along the vector A, and it is given by A dot B, the dot product of the vector A and B, and divide this thing with the magnitude of A. And this is called the scalar projection. And what is the vector projection? Vector projection, it will be a vector, the projection of B along A. Okay, it is denoted by this thing. It is given by the dot product of AB divided by the magnitude of A. Here we write the square, and it is multiplied with the vector A. So this is the same like here, the x and xi. So this is called the scalar projection of the vector B in the direction of A, and the vector projection of the vector B along A. So let's do an example related to this, and in this example we are going to calculate the scalar projection and the vector projection of A along B. Okay, so let us solve this question. So what is given to us? We have two vectors. Okay, we are given two vectors B and A. What he is asking us? He is asking us find the scalar projection and the vector projection of B along onto A. So the first thing you need to do is to find this thing, A dot B, because it is used in both of these formulas. So what is A dot B? You can use the above formula. So it will give you -2 multiplied with 1 plus 3 multiplied with 1 plus 1 multiplied with 2. And if you simplify this thing, you will get -2 plus 3 plus 2. The -2 cancels with this one, and the answer will be equal to 3. So A dot B is equal to 3. The next thing in both of these two formulas, we need the magnitude of the vector A, and it can be obtained by this thing, -2 square plus 3 square plus 1 square, and if you simplify them, you will get following: 4 plus 9 plus 1, which is equal to under the root 14. So this is the magnitude of A, and the magnitude of A square, it will be equal to 14. And now you can substitute these values, let's say, in this formula number 1. Okay, so what is the scalar projection? Okay, so what is the scalar projection? The scalar projection, it is given by this formula, the component of B along A, and it is equal to A dot B divided by the magnitude of A. What is A dot B? A dot B is equal to 3, and the magnitude of A, it is equal to square root of 14. So this is our answer for the scalar projection. And what is the vector projection? What is the vector projection? The vector projection, it is denoted by this thing, PROJ. This is the projection of the vector B, and in the subscript you need to write A, which means that we are finding the projection of B in the direction of A, and it is given by this A dot B divided by the magnitude of A square, and this thing, it is multiplied with the vector A. Now substitute these things. A dot B is equal to 3, and the magnitude of A square, it is equal to 14, multiplied with the vector A, which is given by this -2, 3 and 1. Either you can stop here, or you can multiply this number inside this vector, and it will give you the following. When you multiply this 3 by 14 with -2, 2 will cancel with the 14, and the answer will be equal to -3 by 7. 3 multiplied with 3, it will be 9 by 14, and 3 by 14. So this is the projection of B in the direction of A.